Welcome back to the deep dive. Today we are cracking open a cold case file from the prehistoric world. We're heading down underway, way down under, both in latitude and in time, to look at a creature with a name that, I have to be honest, sounds less like a scientific classification and more like a comic book supervillain.
Or a really expensive piece of gaming hardware. Ultrastenos.
Ultrastenos. It just sounds intense, doesn't it? Prepare to face the wrath of Ultrastenos. But as we've been combing through the source material for this dive, specifically some incredible detective work from the Queensland Museum involving researchers like Paul Willis, Adam Yates, and Michael Stein, it turns out this animal is actually a perfect case study in how messy paleontology really is.
It really is. I mean, we tend to think of fossils as these immutable truths. You dig up a bone, you know what the animal looked like, end of story. But this story is all about mistaken identity. It's about how we interpret broken fragments, how gravity and time can literally warp reality, and how a creature underwent this massive makeover. It went from being described as this needle-nosed, gharial-like specialist to something completely different, all because of how we interpret fractures in fossils.
The total makeover story.
Yeah.
But before we get to the twist, we need to ground ourselves. We were in the Late Oligocene period, roughly, 28 to 23 million years ago? Geographically, we're in northwestern Queensland, Australia, in the Riversleigh World Heritage Area. Now, I know Riversleigh is legendary in fossil circles, but set the scene for us. This isn't the dusty red outback we see in Mad Max.
Oh, far from it. If you go to Riversleigh today, it's all Spinifex grass and blistering heat. But back in the Oligocene, this was a lush, dynamic environment. We're talking about a karst landscape. So think limestone, porous rock full of holes, caves, and underground drainage systems. On the surface, you had open forests, but the water system was unique. It wasn't necessarily these massive flowing river deltas like the Amazon. It was likely a system of forest lakes and ponds that were really rich in lime.
And that lime is key, right? Because chemistry is kind of the unsung hero of paleontology.
Absolutely. Lime-rich water is basically a fossil factory. It coats the bones in calcium carbonate, essentially turning them into rock very quickly before they can rot away. That's why Riversleigh is one of the most important fossil sites on Earth. It preserves things that usually just disappear. And swimming in those lime-rich ponds was the subject of our deep dive.
So our mission today isn't just to list facts about a dead crocodile. We want to understand the detective work. We want to see how mistakes happen, how they get fixed, and, this is the crazy part, how two completely different fossil discoveries, separated by decades, turned out to be the exact same animal.
That is the aha moment we're building towards.
Let's get into the timeline, because this really does play out like a mystery novel. Section 1. A Tale of Two Fossils. The story really kicks off in 1997.
Right. In 1997, paleontologist Paul Willis is working at a spot in Riversleigh with the evocative name of the White Hunter site.
I love the site names at Riversleigh. White Hunter, Low Lion. It just adds to that adventure vibe.
It does. So at White Hunter, Willis finds a snout, just the front end of the animal. Now, looking at this snout, he sees it's heavy, it's robust, it looks like it's built for taking a beating.
And based on that heaviness, he connected to a known group of Australian crocs called baru. And baru isn't exactly a delicate flower, is it?
Not at all. Baru is often called the cleaver-headed crocodile. I mean, imagine a crocodile with a head shaped like a sledgehammer. Very heavy, very dangerous, massive crushing power. Willis thinks this new snout looks like a cousin of Baru, so he names it Baru huberi.
Okay, so we have finding number 1. Baru huberi. Heavy built, typical crocodile vibe. But the sources mentioned there were other pieces found nearby that didn't quite fit the puzzle.
Yes, and this is where the messiness of the field comes in. At that same site, they found some skull tables, you know, the flat top part of the head behind the eyes. They were found near the snout, but they didn't snipe together. There was missing bone in between. So as a scientist, Willis couldn't ethically say these definitely belong to the same animal. They just remained mystery pieces, just sitting in a museum drawer, labeled but unassigned.
Waiting for their moment. Okay, fast forward almost 20 years. It's 2016. A different team, led by Michael Stein, is working at a different location, the Low Lion site.
And they strike gold. They find a back of the skull and a lower jaw, a mandible. But when they look at this jaw, they see something shocking. The jawbones, they seem to converge really rapidly. They angle inward sharply, suggesting that the snout of this animal was incredibly long and thin.
Like a pair of needle-nose pliers. Or like those gharials you see in India.
Exactly. A specialized pin-thin snout. It looked so radically narrower than anything else found in Australia that they decided it needed a name to reflect that extreme anatomy. They combined the Latin ultra, meaning extreme, and the Greek stenos, meaning narrow.
Ultrastenos, extreme narrow.
And they named the species Ultrastenos willisi, honoring Paul Willis, ironically enough. So as of 2016, the scientific consensus was that we had two different animals. We had Baru huberi from 1997, which was a heavy-duty cruncher, and Ultrastenos willisi from 2016, which was this delicate, needle-nosed fish snatcher.
Two different animals, two different ecological niches. One crushes, one snatches. That was the picture.
Until 2024?
This is where the plot twist happens. Adam Yates and Michael Stein publish a breakthrough paper. They decide to do some housekeeping on the collections and take a closer look at those old mystery pieces from 1997.
Specifically, that skull fragment Willis had found but couldn't place. They took that piece and they took the original Baru huberi snout and they tried to fit them together again. It wasn't just a maybe, it was a lock. The edges were parallel. It turns out there was a fracture where the bone had broken apart, probably due to erosion or weathering before it was even collected. When you put them together, it wasn't just two animals of the same species. It was likely the same individual animal.
That is just statistically wild.
Yeah.
I mean, think about the odds. You dig up a snout, then decades later you realize the back of the head was sitting in a drawer the whole time.
It's the paleontological equivalent of finding the other sock in the dryer 20 years later. But this created a domino effect. Once they had the whole skull reconstructed, they could look at the ornamentation, the bumps and ridges on the bone. And guess what? That ornamentation matched the 2016 Ultrastenos finds perfectly.
So Baru huberi and Ultrastenos willisi are the same animal.
One and the same?
But wait, they have different names. One is Baru, one is Ultrastenos, one is huberi, one is willisi. How do you decide what to call it? It sounds like a legal nightmare.
It's less legal and more bureaucratic. We have to consult the rule book, the International Code of Zoological Nomenclature. The core rule is generally priority. The first name published wins.
So huberi wins because it was from 1997.
The species name huberi wins, yes. But the genus name Baru was incorrect because this animal clearly wasn't a Baru. It was distinct enough to deserve its own genus. So the valid genus name is Ultrastenos, which was coined in 2016.
So you just mash them together?
You get Ultrastenos huberi.
And Ultrastenos willisi.
It becomes a junior synonym. It's essentially invalid now. It's a ghost name in the history books.
Puro willisi. But okay, we have a name, Ultrastenos huberi. But this creates a huge problem, doesn't it? As we established, the name Ultrastenos means extreme narrow.
Correct.
But the 1997 snout, the huberi part, was described as broad and short, and the 2016 jaw was described as extreme narrow. If they're the same animal, how can it be both broad and narrow? Did it have a shape-shifting face?
And this is what we call the Pinocchio problem, or maybe the reverse Pinocchio. The name describes a feature the animal literally did not have. And this is where the science gets really interesting, because it's about taphonomy, the study of how organisms decay and become fossilized.
Let's dive into that, because looking at a jaw and thinking it's needle-thin when it's actually broad, that seems like a massive miss by the 2016 team. How did that happen?
Well, it comes down to the condition of the fossil. The 2016 mandible, the lower jaw was broken, it wasn't attached to the skull, and crucially, the left jawbone was bent inward significantly more than the right one.
Ah, so it was warped.
Exactly. We call it plastic deformation. I mean, think about it. These bones are sitting in the ground for 25 million years. Rocks shift. Pressure builds up. Even stone can warp if you give it enough time and pressure. It's like leaving a vinyl record in a hot car. It's still the record, but the shape changes.
Well, that's a great analogy. So the bone was kind of melted inward.
In a geological sense, yeah.
Yeah.
And when the researchers in 2016 reconstructed it, that inward bend created an optical illusion. If you followed the angle of the bent bone, it looked like the jaws were converging into a super thin point. But in the 2024 revision, Yates and Stein realized that if you digitally unwarp that bone, rotate it back to its natural position, it doesn't make a needle shape, it makes a U shape.
So Ultrastenos, the extreme narrow crocodile, actually had a short, flat face.
Ironically, yes.
Okay.
It was platirostral, flat-snouted, and brevirostrine, short-snouted. The name is now a permanent misnomer. It's named for a feature it never actually had.
That is fantastic. It's like naming a dog spot and then realizing it has stripes. But surely the shape of the jaw isn't the only clue. If I'm trying to figure out what a crocodile eats, I'm looking at the teeth.
And the teeth tell the real story here. This is why the long snout theory should have been suspicious from the start. Think about what a long-snouted crocodile eats, gharials, for example. They are specialized fish traps.
Right, they sweep that long, thin head through the water sideways to catch fast prey.
Speed is key. And to catch a slippery, fast-moving fish, you need teeth that act like a cage. You need long, needle-like, interlocking teeth. Snap, and the fish is pinned.
In Ultrastenos.
It didn't have needle teeth, it had molariform teeth.
Molariform, like our molars.
Similar function. They were low, rounded, and robust buttons of bone. These aren't for piercing, they are for crushing. If you tried to catch a fast-moving fish with these teeth, it would just slip out like a wet bar of soap. These teeth are built for high pressure. They are built to crunch through shells, bones, and armor.
So we have a short-faced, crunching crocodile. Paint a picture for me. What did this thing look like when it was alive? Was it big?
Surprisingly small. We're talking about 1.5 meters, maybe 5 feet long, similar in size to a modern Australian freshwater crocodile.
So relatively cute-sized.
Relatively. And it had some distinct features. The nostrils were right at the tip of the snout, facing slightly forward. And the eyes, this is interesting, it had very large teardrop-shaped openings on top of the skull called supratemporal fenestrae.
Teardrop eyes. Sounds poetic, but I assume those holes are for muscles.
Exactly. The fact that those openings were so huge suggests massive jaw muscles. This animal had a very powerful bite for its size, and the jawline wasn't straight. It had festoons?
Festoons?
Yeah.
Like party decorations.
Like waves. The tooth row curved up and down, which again helps with holding onto prey that you're trying to crush. It creates locking points so the hard shell doesn't slide out.
Okay, so we have a clear avatar now. Small, 5-foot, short-faced, muscle-headed crocodile with crushing teeth. Let's talk about its life. You mentioned Riversleigh wasn't a desert then, but it wasn't exactly a massive river delta either.
No, the low-lying site where the 2016 fossil was found was likely open forest. It was a karst system, lakes and ponds that drained through limestone.
And these water bodies might not have been permanent.
Exactly. Like modern freshwater crocs, Ultrastenos might have had to deal with water levels dropping or ponds drying up seasonally. It had to be adaptable.
It wasn't alone, right? I imagine 25 million years ago, Australia had some scary wildlife.
Oh, absolutely. Ultrastenos was living alongside giants. At the White Hunter site, it coexisted with Baru-Wicini.
That's the real Baru.
The real deal. And Baru-Wicini was massive, heavily built, a top predator. If Ultrastenos is a compact car, Baru is a semi-truck.
So how does a 5-foot Ultrastenos survive next to a giant Baru?
Niche partitioning, basically staying out of the way and eating different things. Ultrastenos was the underdog. It was small enough to hide in the shallows or the denser vegetation where the big Baru couldn't go.
And the diet. You said it wasn't eating flesh because of those crushing teeth.
That's the current theory. Originally, when they thought it had a long snout, they assumed it was a piscivore, a fish eater. But now, with the short snout and crushing teeth, plus the fact that fish fossils are actually surprisingly rare in that specific part of Riversleigh for that time period.
Wait, rare fish fossils? In a lake system? That seems counterintuitive.
It does happen. Sometimes the chemistry doesn't preserve them, or maybe the ponds were isolated and seasonal, so fish populations just couldn't get established. But because of the teeth and that scarcity, the new theory is that Ultrastenos was eating small land animals. Frogs, snakes, birds, maybe small mammals.
Crunchy snacks.
Exactly. Snails, crustaceans, anything it could grab and crush.
This brings up a really fascinating point that the source has highlighted. It's what they call the implications for Mekosuchinae. And this leads us to the mystery of the ghost niche.
I love this concept. So Mekosuchinae is the group Ultrastenos belongs to. It's a specific group of extinct crocodiles from Australia and the South Pacific. And here's the weird thing. Unlike croc families in the rest of the world, Mekosuchines never really evolved that classic long-snouted gharial-like shape.
Which is strange, right? Because if you look at South America, Africa, India long snouts pop up everywhere. It's a great design for catching fish.
It's a very successful design. Convergent evolution usually makes it happen. But in Australia, nothing.
And Ultrastenos was supposed to be the answer. It was supposed to be the missing link that proved Australian crocs did do it.
Exactly. It was the one exception. But now that we know Ultrastenos actually had a short snout, well, the exception is gone. The mystery is back.
Why not? Is there something about Australia that just hates long snouts?
There are a few theories. One is developmental constraints. Maybe their genes just wouldn't allow that shape to form easily, similar to how modern alligators rarely get super narrow snouts. But the more compelling theory ties back to the environment.
The drying continent.
Exactly. If the water bodies in Australia were becoming more seasonal, drying up into mud puddles every year, being a specialized fish eater is a risky strategy. If the fill die out when the pond shrinks, you starve.
So you need to be a generalist. You need to be a Swiss Army knife, not a scalpel.
Precisely. If you have a short, broad snout, you can eat a fish if you find one, but you can also eat a wallaby or a frog or a snail. You survived the bad times. So maybe the Australian landscape itself forced these crocodiles to stay generalists.
It's the ghost of a niche that nobody could afford to fill. That is such a cool concept. It frames evolution not just as what is the best design, but what is the safest bet.
And in Australia, the safe bet is usually adaptability.
Let's quickly look at the family reunion before we wrap up. We established it's a Mekosuchine. Is it related to the modern saltwater crocs we see in Darwin today?
No, and that's a common misconception. The salties and freshies in Australia today are relatively new arrivals, immigrants from Asia that came over in the last few million years. Ultrastenos and its kin are the original Australians. They were there for tens of millions of years before the modern crocs showed up.
And despite the old name Baru huberi, it's not closely related to the giant Baru, right?
No, they are distant cousins within the Mekosuchine group. Ultrastenos sits on a different branch. It's actually closely related to a creature we haven't even officially named yet, referred to in the papers as the Bullet Creek taxon.
The Bullet Creek taxon sounds like an X-file.
It does, and it's also on the branch with the dwarf Mekosuchines, animals like Trilophosuchus and Mekosuchus.
Trilophosuchus is that tiny land croc, right? The one that looked like a little lizard.
That's the one. So Ultrastenos confirms that there was this distinct lineage of small-bodied, short-snouted crocs evolving right alongside the giants. They weren't just baby giants. They were their own thing, doing their own evolutionary experiment.
So what does this all mean? We've gone from a comic book villain name to a tale of two fossils, a glue job that solved a 20-year cold case, and a total anatomical reimaging.
I think the biggest takeaway is scientific humility. The name Ultrastenos, extreme narrow, will likely stay. It's the official valid name. But it describes a feature the animal didn't have. It is a permanent, Latinized reminder that we can get things wrong.
It's honest, though.
It is. It shows science working as intended. New evidence comes to light. In this case, Yates and Stein realizing those fractures matched, and we correct the old assumptions. We don't stick to the old idea just because we liked the name or the cool factor of a long snout.
And it reminds us that fossils aren't just rocks. They were living things that broke, decayed, and got squished over millions of years. Reconstructing them is really hard work.
It's a 3D puzzle where half the pieces are missing and the ones you have are bent.
Before we wrap up, I want to leave you with a final thought on that ghost niche. Long-snouted crocodiles appear almost everywhere else in the world. They are efficient, but not here.
Not here.
If Ultrastenos wasn't the one, and the Mekosuchines never did it, is there something about the Australian landscape itself that is fundamentally hostile to specialization? Is the hydrology of the continent, the way the water flows and dries up, so harsh that becoming a specialized fish eater is a death sentence?
It's a fascinating question. Did the drying of the continent kill off the potential for that lifestyle before it could even start? Or is there a fossil out there, still waiting in a limestone block at Riversleigh, that will prove us wrong again?
Maybe we'll find the real Ultrastenos one day. But for now, we have Ultrastenos huberi, the short-snouted crocodile with the ironically extreme name.
A small croc with a big story.
Thanks for diving deep with us. Keep questioning what you see in the museums. Sometimes the labels only half the story.
See you next time.
Catch you on the next deep dive.